Half of our class is gone.
You didn't give me 4.
You're not over here.
Okay, well, I'll come over.
Okay, so outlines on the board. If you can't see it from over there, apologies, but domain and range is going to be one of our topics we talk about with functions. Stop. Domain and range, discrete versus continuous, and that's going to lead us into sets and
Oh my
intervals.
gosh, we learned that.
Yep. Then we're going to talk about independent versus dependent. That goes with the whole domain idea, and that goes with the sets and intervals and stuff. That's going to then lead us into increasing versus decreasing functions. And once we're through that, then hopefully we can get to like talk about proportionality, talk about proportional functions. And there's different types of proportions, and then we'll get eventually to linear. Linear will be what we do today and tomorrow, and we'll see how long it will take us. This is the one that we need to spend probably the most time on practicing. Not today, but just because it's been so long. I don't think you guys really had to do linear functions since Algebra 1 days. So we really needed to discuss that. The one that will be probably the most challenging is probably sets versus intervals. Okay? Alright.
Oh, we've already done that.
Yeah, we did it in pre-calc, but we need to make sure we know how to do it, because that's like one of the first things we have to make sure you have a handle on, especially when I show you a graph and we talk about it.
Understand.
Okay, alright.
Make sure you get a handle on.
Questions?
No.
Perfect.
Your favorite
Wait,
mayor.
will we need a...
No. Nothing relevant.
Calculator today?
No.
Like, this is really hard not carrying my backpack around, so like...
Yeah,
You'll be fine.
Yeah, we're
Manage it
gonna
up
have
to
to change that.
like I was like,
I don't like
this is
it.
right.
Gonna have to
This
change
is
it.
an object below.
Okay.
Yeah, I forgot my calculator.
Alright. Hey, let's talk about functions. Definition.
I still forgot it. Shut up.
Okay, let's talk about a function. Function is a particular thing in mathematics where for every element.
Did you do anything in retail for
Business
today?
before.
Do I need to take
What
this?
for?
Hey, let's cut out the conversations. It's getting annoyed by it already. Okay, for every element in the domain, there is exactly one and only one. There is exactly one and only one in the range. By one, I mean one element in the range.
Would you read that again one more time, but very slowly?
Yep. The range.
Can you slow down or something?
Add an extra word in there. Okay, I'm going to read it. Hopefully you're writing it down. It's some type of mathematical function or formula that what it does is that for every element in the domain, for every number you enter into it, it's spitting out one and only one answer. That's a function. Most people see functions in Algebra 1, a lot of the times in the first couple weeks of Algebra 2, but the minute you get into any type of curve, so parabolic, hyperbolic, circles, ellipses, now you've entered a realm where there's not functions, because for every x number or every input, there could be two answers coming out depending on how the line is curved. So, that's the definition of a function. The best way I can explain it to you, it's like a calculator. Okay, you take numbers, you enter them into the calculator itself. So here's my calculator.
That's a good calculator.
All
You're gonna
right.
need extra
So
12.
now the numbers you're entering.
There's no enter button.
This is your domain.
You can just type it.
You can enter certain numbers into it. What should happen? It should spit out a range. The big thing is, there are certain calculators, I know those upper level calculators like TI-89s and 84 pluses, they can handle it if there's more than one correct answer. It can give you a plus or minus. It can potentially tell you that there's a set of numbers that will work in that realm, but most calculators can't, especially like simple ones like this little piece right up here, right? It'll give you one answer, okay? It shouldn't have to make the logical choice of two because the programming isn't there for it. This is a perfect example of what a function is. This would represent your function. Now, most people will see a function like a linear equation, something like this. Here's your example. Y equals 2x plus 1.
Oh my gosh, I was thinking that.
That's an example of a function. Okay, you enter a number in for x, it spits out a y. One single number. It's pretty easy. No matter what number you plug in, it'll have a y number that comes out of it. Because it's easy. Just plug it in, times 2, add 1. Boom. So, what we're going to be discussing is the parts. Because obviously we're going to be doing a lot of functions this year. Lots of different things. We'll be outside of the function realm, so we'll be dealing with things that are curves. And we're going to be looking for answers. Well, we need to start with the basics. What happens when there's one solution? Then what happens if there's more than one? Can we answer those correctly if there's a case where that were to happen? So today is just to talk about the basics, the parts of just a normal function. Question?
How do you program a calculator to give you right answers?
Very careful.
Like even a simple one, how do you make it know what it's doing?
The basic laws of mathematics, like addition, subtraction, multiplying, and divide, are just basically programmed into
Yeah,
it.
but how do you do that?
Just for if you type in 2.
Ones and zeros.
It just literally has the same set of all the numbers that those will add to.
Exactly. Multiply.
Multiply and divide.
That's a lot of,
Yeah, that's why certain calculators have a certain memory type. That's why the screen is so big, it won't go past a certain number, because the memory runs out.
Fly right now.
So, okay, now, domain and range. I've already put them on the board. I've talked about the words in the definition. Domain are the numbers you enter. So, let's write this down. Domain is the input. It's the input. It's the thing you're in control of. So really, this is the independent variable. The independent variable is the thing you're in control of. You enter it into the calculator. You hit enter. The thing that the calculator spits out is the range. Range, that's output. Okay, that's dependent. It depends on what you enter. There are certain cases where you might get an undefined boundary. There's no answer to that problem. Because the issue is that depends what the domain is. The domain might be limited. There, like that function there, y equals 2x plus 1. You can enter any number you want, decimals, fractions, negative numbers, it doesn't really matter. It takes all real numbers. A function like this, which we're going to discuss today, this has a limit. Like, there's a certain number you cannot use in there. It only has one of them, but that's the one number you can't use. So there's a limit to the domain, so there's a limit to the range. It's not continuous. So it's going to have an issue at one specific number.
Is it that bad?
Okay, questions on the idea of domain and range and what the input, the output, dependent and independent. Okay, the big thing is, I know the book uses the word independent and dependent a lot. It's just X versus Y. That's basically what it is. What you're entering, what you're outputting. The big thing I want to make sure of is you understand the vocab, so you're not overwhelmed by it. Because these are easy concepts. You learn them back in Algebra 1, you learn them in Algebra 2. I'm just trying to clarify them so you feel more comfortable before we get into the bigger topics. Okay, now let's discuss one other thing. Let's talk about what discrete and continuous means. Okay, discrete. A discrete function has a certain limiting domain to it.
7.
3. It could be as easy as you're making a function. Hey, so it's as easy as you're entering a function where you enter a date and it outputs maybe the temperature or the weather that day.
The year.
Well, so that's what the weather app does, right? You type in the date, boom, it spits out the temp, what it thinks it's going to be that day, or in the past, maybe just had it pre-organized in for it. So the idea is that discrete is there's certain numbers you have, so the domain is limited. That means the range will have a certain number to it. So what I always say is, like, if you're thinking about discrete functions, the function can't use all real numbers. There's a limit to it. Like, for instance, maybe it only takes integers, whole numbers, like 1 through 30. Maybe that's the calendar date. Maybe that's what it'll only take into it. So just be careful of that. Okay. If it's continuous, it can take anything.
Like weight.
Yeah.
Yeah.
I mean, Well, maybe not weight. I guess you could make a function with weight. The problem is like you can't be a negative. So I'm thinking of like anything that wouldn't have a limitation to it. So I was thinking more like a bank account.
Helium.
No.
Doesn't have it.
Fine. Science joke, really. All right, but a continuous function would be something where you could use any, you could use anything for the domain, so it's not limited. So all real numbers work for the domain.
Yes, sir.
That would be continuous function. It's flowing. You'll get a sense for if a graph is continuous versus discrete. Continuous graphs are what most calculus you want to have happen. You want to have a continuous function. For every input, there's always an output. If it's discrete, there might be breaks. The best example of a discrete function I can give you is like a piecewise function. Different graphs going on. There's breaks in the graph. It doesn't have everything out. There's no output in certain cases because maybe it won't allow it. So there's a clear difference there between continuous and discontinuous. Now, the hardest part is not the two words. The word's easy. You can see it, discrete versus continuous. It makes sense, the actual words themselves. What really challenges people is the sets and the intervals you can write their domain and ranges into. So we'll start with a domain for like for a piecewise function. I'll draw a piecewise function on the board. We'll talk about its domain. Then we'll do a continuous function. We'll see the differences that you can have. Okay? So that's what we're going to go into. This is something that you saw last year. We spent a lot of time in pre-calc talking about it, but it's still something that people struggle with, is the idea of interval notations. People don't like it. They don't understand it, so we need to practice it, because it's one of those things we're going to have to take for granted. Okay? Then after that, we'll talk about increasing and decreasing functions. And hopefully we can get to these last ones. I want to really talk about linear if we can get to it today. All right, well let's do a graph here. I'm going to try to do a graph that, it's not continuous, it's got a break, it's a piecewise function kind of thing. There's certain numbers I'm limited to. All right. Okay.
Well,
Let's see.
we're done for the day.
There it is. Okay.
Rusty, what did you do earlier in college
Okay.
bio? You just stopped talking.
I wasn't
No, one day closer.
laughing.
No, one day closer.
Actually, it's working.
Good stuff with that.
Okay. So, all right, what I have on the board, it is a piecewise function. There's two different things going on. Now, this one, it's not flowing continuous. Now, the problem is that there's arguments that it's not also discrete, because it's using pretty much all the real numbers. It's just, it's not continuous. So, I would not classify this graph as discrete. The reason being is that it's using almost all the decimals, all the numbers. It's really hard. It's super difficult to write this thing as discrete, because when I think of the word discrete, I think of something like this.
But you don't use one.
Where, yeah, I mean, there's a couple numbers you're not using there,
Well, there's an infinite amount of numbers you're not using.
There's like little dots.
but discrete's more specific. It's like when you're limited to just the integers. Just the integers. Like this thing has a lot of decimals and a lot of other numbers. It's not just one set of numbers. So I would just say that this is a piecewise function, it's not continuous. I wouldn't label it as discrete, because discrete is like when I'm thinking like the domain, all the x numbers you can use. You can't just write it like this, where you can just put breaks. There's too many. There's an infinite number of numbers I can use. There's too many in between. I mean, there's ways you could write this where you could use, what I'm using here, this is called roster method, where you could do set builder, where you do like all the x's such that x is less than -2, and x is greater than or equal to what?
No,
2?
you're supposed to do it the other way.
I don't know, I could write it any way I want.
You said X is greater than
Oh, pretty, wait a minute. There. Less than -2, but it's greater than 2. I can use that. That's an idea where I can have a break in the graph. Some people really like the set builder notation, where you can set the limitations, like you can be above this and below this. It's just that there's too many numbers. I know like most people say, hey, it's discrete. It's not using all the numbers. I agree with that. It's just that when I think of discrete, I'm thinking of like you're only using a select few numbers.
Are you saying that it's technically discrete, you just don't think of it that way? That's
No,
how it's come across.
the book,
Yeah.
no. Some people would say it's discrete. I'm not saying that. I'm saying it's not.
What does the book say?
The book says not continuous.
That's
So it's
how
discrete.
saying.
And the hard part
Discrete
is,
or not?
I gave you 2 categories, right? I gave you 2 categories earlier.
You gave me discrete.
I gave you
not
discrete and
You
continuous.
said it's not discrete, but you said it's not discrete.
Yeah. Well, the problem is most people look and go, you only gave me 2 options. It's discrete or continuous. It's not continuous, but it's not discrete
Why?
because it's not just limiting like you're just going to the integers. I'm using all the decimals too.
So there's an
I can't
infinite amount of
list them off in a
decimals that you
simple
can't
list.
have.
I can't list them off in a simple list.
That's
So-
Sorry, I didn't get it.
Yeah, the best way I think of it is like, discrete is when you're limiting just certain numbers where you could list them off on a piece of paper.
Okay,
Continuous, you're using all numbers.
okay.
So there's this weird like third band that the book never really talks about.
And that's this.
That's this.
Alright, that's enough.
Okay.
Should we just write this on a test then?
We just write weird third band.
Alright.
So that's what this is.
Now, okay, so these are the 2 options. This is roster method, this is set builder notation. They make sense. The thing is, we have that other method we use to write notations, okay? The other way that we can write, other than set builder, and you know that other one which is roster method, is we can use interval notation, which is the one that I tried to get you guys to use a lot last year. This is what it looks like, and I'll show you why there's a problem with it. Or, not a problem with it, but the way that people look at it, and I can understand where they're coming from. Okay, it's like this. It's when they go, I'm going from neg infinity up to 2. I'm writing it like that.
Union.
Okay, yeah, and we'll talk about unions and stuff. Okay, what you're looking at here and why this is a problem is that most people look at that and go, board, you just wrote a coordinate on the board. But it's not. It's an interval notation. How you know is depending on what the question's asking for. Is it asking for an intersection or is it asking for a domain and range? If it's asking for a domain and range, this might represent the domain of it and it could represent an interval. Now, how you also know is it has an infinity sign in here. That kind of gives away it's supposed to be an interval. Because infinity is not a number, it's a direction. So the idea is that this is definitely talking about the domain of this thing. So what we're looking at here, this function is an open interval. What I mean by open is that it does not include the end caps. It's an open interval. Okay? Yeah. If it includes, we'd have a bracket. So this is an open. Do you see that we went towards infinity? And notice I didn't use a bracket because infinity is a direction. I can't just pick a number at random. And it came down to 2 for the x, and again, negative 2 I should say. I used negative 2 in this case, so it came there, but it didn't include it. There's an open circle there. Then I heard Justin said earlier,
What
we
did
do
I
a
say?
Union.
We do a union,
Oh yeah, we did.
and we attach the other one, because there was a break in the graph. Unions when you just add both sets together and it makes the whole thing eventually. So we do a union, because you're adding, and now at the next part, this is where I'm going to start with 2. I'm
With
gonna
a
start from
closed bracket or.
And yeah, you gotta use it close, because it's an actual filled-in circle there. 2, and we're going up to positive infinity, and we use a parenthesis because infinity is not a number.
Mr. Ward,
It's a
it's
direction.
parenthesis.
Come on. You know
It is
this.
in parentheses here.
Parentheses.
Alright,
Parenthesis.
hey, so, do we understand what a union is though? You're
Yes.
adding 2 things together to make one answer. I like this notation. It's clean, it's easy, I don't have to try to come up with this thing. You've already saw me butcher this. I don't like when you have to build it, you have to think about what numbers I'm in between or not in between. I just wanna set the numbers, you know, what I have. Where this can be difficult is when we have to write range. Range is just Y numbers, not X numbers. This is the difference here is that the range may not be a union. The range might just be from one number and up, because like this one, do you agree that arrows are kind of pointing up? So the lowest number we have is a 2, and we're going up from there. So the range will look completely different. So this was the domain,
What's the end thing? When you flip the union over?
and that's intersection. It's where they like overlap.
That's the competitive.
We can talk about that here in a minute. Okay, now the range.
Is that part of this at all?
Yeah, we'll talk about it here in a minute.
Oof.
Okay, now range, just the range. What's the lowest number on the Y's that I'm hitting?
Negative.
Negative 1? Negative 1? And it looks like it includes, there was a solid dot there. Negative 1, so I'm having a bracket here, that's the smallest number, and then we're going up towards positive infinity. It's going up. I know there's like this weird break in the graph, but over here it was actually filled in. So I'm actually including all the numbers up, even though that one was open, it was at least filled in over here. So, from negative 1 up to positive infinity. Now, the thing that people get wrong when they write this, they use the wrong number for the range. They forget they're supposed to use Y numbers, not X numbers. And the other thing that they forget is that you have to go least to greatest. So anytime you write one of these, intervals, it has to go the small number first, the bigger number after it's second.
Wouldn't you think
Small
negative
to big.
infinity was a big number?
What was that?
I think it's a
Negative
tiny number.
Negative
tiny.
infinity.
Super tiny.
It'd be huge.
No, it would not.
Super tiny.
It'd be
The
huge.
absolute value of
Usually
it.
Trust me, 100
Did you
is a
think about
lot.
If you think
That's
about-
gonna be pretty big.
I weigh negative infinity pounds. That's a lot not to weigh.
What if you put the
I
absolute
don't think that
value
works.
of-
It does.
What if you
Trust
weighed
me,
the
100
absolute value of negative infinity? Then you would
Okay.
be a lot.
Ooh.
You'd be like,
Oh my god.
Oh
That's
my
not
God.
actual
The cardio you run.
I didn't.
Okay, hey,
Yeah.
alright, so now, Josh, to answer your question.
Oh.
Okay, we talked about unions. Where there can be an intersection is maybe they want to know the intersection of the range. So they could say, okay, where on these two graphs, there's two separate graphs, is there an intersection on the range of these? Yeah,
Sure.
there's a spot where they overlap.
Spark.
Yeah,
Don't
there's a
catch
spot
on
where they
fire,
overlap.
spark.
It overlapped here and up. That's where, if you're looking at both graphs, they eventually overlap. Now, we won't include,
No, wait,
That-
they don't
that
actually
two-
intersect there because it's not, it's not included.
I'm not saying like they physically cross, I'm saying the range numbers,
The range.
the range numbers were overlapping. So,
So let's do it.
so the intersection here would just be from here and up. It's actually just set numbers. So, where they intersected was from 2 and up. So,
Open
we
bracket.
won't include 2. But we'll go up to positive infinity. That's where the overlap happens for the range, the intersection. Now you're thinking, well, Dressy, you just asked like, what's the flip over of it? You could write it as an intersection of like the two, but you could write both things individually, both ranges, and do an intersection. This is the shortcut for doing it. So, because that's the answer, right? You could do something like this. It could go from, one of the ranges is from 2 up to positive infinity,
What you talking about before?
and we're doing an intersection of the other one, which was from -1 up to positive infinity. Right, that's this range,
Negative one is a
that's
though.
this range, like separated, but the intersection means this. It's where they overlapped, technically in the range.
Does that need to be a bracket?
Which one?
Negative one.
Yeah, sorry, yeah, that should be right.
Should be a
Okay, but
parenthesis.
I have a question.
So like this?
You prefer this way instead of the other?
I do. I do prefer this way, just because it's way faster to
It really
write.
is.
And, I mean, because you can do differently, like, these mean the same thing to me.
Listen, ask me how to put this.
Some people can understand, like, where they overlap versus not, but it's just more clean. The only reason why I understand people don't like it is because it does look like coordinates. So I just prefer, it's just, I don't like set builder. There's just too many things, too much structure.
Right?
You have to think about it too long. This stuff's way faster. Question?
How do you prefer your eggs?
Scramble.
Scrambled.
With cheese
Always
or
fried.
no?
You put
I
like,
only
you
use
put like
scrambled
milk in it and then
eggs.
mix it up, or do you just?
Would you eat a boiled egg or a
Way
soft
faster.
boiled egg?
No.
What?
Trusty, ask for soft
Don't
boiled
do
egg
that,
at
Mr. Ward.
Perkins.
It's like
She's
a
like,
hard
we
boiled
don't.
egg, but the yolk is still running.
She asked for one at Perkins. She's like, we don't have ones here actually.
Her brother told me that was the only thing they
It
had.
was like one.
She asked for
One
soft
egg,
boiled.
that was pretty good.
And the girl was like, I don't know what that is. Here's what you want.
Okay, all right, hey, here's what I want. On this next one, I'm gonna draw a graph,
And we're gonna do it.
and I wanna see the domain of it, okay? Write it down on your notebook paper, I wanna see it. We gotta get some practice.
Can I keep it?
Okay, here we go. Nope,
We have all this boardroom.
I know, we're gonna use them later. We'll use them later.
We We have this marker board space, Mr.
We'll use it later. Now, hold on. Okay, so the first graph, here we go.
I'm not really sure what's going on.
Watch me.
And yes, I will label things.
Thank you.
Thank you, Mr.
Will you,
Ward.
Yes, you will have.
You don't trust Mr. Ward's word?
No.
Use parentheses if it's inclusive or not included.
What are you doing?
I don't like this. We gotta stop right now.
Yeah, wait, you're going too far.
Now I'm gonna.
This is the first day of class you do it, like
I
kind
like
of.
those little numbers.
What is that?
I can't see that.
I want to
Negative
turn on
eight?
my brain today.
Yeah. Why, thank you.
Jaden, step one is always to turn your brain on. You
It's
gotta
always
remember
on.
that.
You didn't label 0.
It's like
So it's gonna
overheating.
kinda
Are you gonna label it?
Your brain, I thought it was off. How can it overheat?
Well, like, no, I had to turn it on today and it's really.
There
What about the other one?
It's just
Yeah,
There's an arrow on the other side.
I understand.
Yeah,
Oh,
so
you
you get it,
need
you
more
get it.
than one or not?
Okay, I want just the domain.
Oh
I
my
don't know what
god.
that is.
Domain is XS.
Hey, I don't want to write on my paper.
I don't have it.
Can there be more than
Well, sure.
2?
Dude, I need a note. I need your
Do there have, is there gonna be a U in between
Both.
all of them?
Thank
Sure
you.
do.
Is that something to
-9 bracket,
Or bracket.
Comma.
Bracket -9.
-5 parentheses.
Hey,
Hey,
you
Justin.
gotta let.
Yeah, can you see it? Context.
Yeah, I wrote a little small,
You
sorry.
had.
Yeah, I'll zoom in on that like with the camera.
Is that a negative?
Where that one dot is.
Yeah.
And then you got another parenthesis at -4,
The third part?
and then a bracket,
No,
Yeah.
I'm not.
comma,
I'm
bracket,
almost
It's
there.
negative
0,
1, not 0.
0 bracket,
What?
and then
You put a 0.
comma,
Oh, I
or
did.
parenthesis,
Yeah, it
1,
literally says 0
Yeah,
right there.
infinity, positive, plus infinity.
All right, now-
Everyone is side to side.
Hey, now, if somebody would like to come up as a volunteer, as a tribute, I'd like somebody to come up here and write the domain up here on the board.
Can you give me this?
Mr. Ward, I kinda want to buy dog.
Hang on.
Yeah, I'll do it, Mr. Ward.
Ricardo, come here. Reach.
Wait, but can I write
Come
something
on.
down first?
How do I get parentheses?
Just come on.
Oh, you want
It has to be a
Can I do
parenthesis.
range?
That's Trinity, right?
Pastor.
That's not it.
Can I do range?
Do you think you
Listen,
can?
right now.
Jared, you want to
Not
do
right now, we're just
tribute?
doing domain for right now. I don't
Lord, I
wanna,
think I
You
actually-
could probably do it.
My schedule does not fit.
that's good, because you get this.
You're
That's good.
busy
I
right
actually
now.
want that down.
Okay, you want me to do it now?
Yes, please.
Okay,
Other people are still working, you can keep working.
Ooh.
Alright, go. Just domain. Just
I need a few more minutes.
We're gonna need 3 to
I
5
don't want
business
an
days.
interval notation.
Look
Dude,
at, she's
I
not
can
even
figure it
taking
out, I can
notes,
figure
look
it
at her
out.
notes.
Justin.
Yeah, he actually
Jimmy,
yelled
she
at
just
her.
did
Are
that.
you serious?
We're gonna need
Look
3
at
to 5
mine,
business
mine are
days to finish
beautiful.
Look at
this.
my notes.
Sure.
I had this thing wrote
I'll show
down.
you.
Yeah, people who don't take notes, like, you're not even gonna pass this class.
Yeah,
You really aren't.
I hate those
Bad.
people.
Obviously, there's a language
I know,
chapter.
those people really don't.
Before I let you go, just make sure the
One
brackets
page
are
per
There's
very clear.
obviously.
Yeah, I can't tell which one is which.
Do whatever you need to. No, don't even. I was just saying, like, hey, I was just saying, like, if you need to, like,
Nicole, it actually helps me if you write half of it in one color and half
Nicole,
in
you have a
another
hair on your
color.
butt.
I only can read red.
She was like thinking about it for a second.
No, you'll read yellow.
If all the parentheses
just want to make sure the parentheses and brackets
are
are
in
pointing.
Parentheses.
yellow, that would help.
Fine parenthesis if it's one
That's the
singular.
Yes, exactly.
There's more than one. Or
Not
parentheses.
all the time.
Not but if you say
negative
-5
5,
parenthesis.
You can't say parenthesis right there.
Fine, say
Wait,
parentheses.
how do you know when to put a thing in this thing?
That's when you're adding a bunch of different ones that are all disconnected.
Yeah.
All their parentheses and,
Yeah.
Okay, alright, hey, let's discuss, thank you for the volunteer. Okay, alright, do we agree with the first one, from -9
Yes.
up to -5?
Sure.
Do we agree with the bracket and parentheses?
Yes.
Okay, why parenthesis? Why do we like the bracket?
Because there's a parenthesis.
Now, why do we like the bracket?
Because
Not supposed to be
Because it closes it.
Okay, it's closed, right? It's got that set number with the dot, the filled in dot. We have the parentheses or parentheses on the other side. Okay, in the middle. What's correct there?
The parenthesis.
everything.
Everything. Parenthesis, the bracket, the numbers.
The nugget
comma.
4,
The comma.
the 0, the comma,
Okay,
The letter
next.
O.
and the points on the
Yeah.
bracket.
1 up to infinity, and that's correct. Now, we had earlier. So Jaden, what do you say about
There's two
the
parentheses.
You always talk about
parentheses?
parentheses.
Always, when there's an
Oh,
infinity sign.
parentheses.
Always, she was correct on that. Okay, now, I like the union. Yes, you can have more than one union. So you can have up to 3, 4, 5, doesn't really matter. You have a bunch of
Holy
breaks.
cow.
Okay, the thing that I really want to stress, make sure you really understand the bracket versus parenthesis. Okay, understand when to use it, and make sure that your number's going least to greatest, small to big, every single time when you're in there. I don't want to see a bigger number. Ooh, geez. Some more. I don't want to see a bigger number over here to some here, okay? Because it's gonna mess everything up, and it doesn't look clean. Least to greatest. I tripped on the imaginary line. All right.
You want me to help you?
No. All right. Now, okay, the next one.
Range.
I want range now in interval notation. Ooh, yeah.
That's your word.
Hey, your shoes are untied, yeah.
I'll tie it.
I can tie it.
I know a cool way.
I know already.
Okay,
Wait.
range,
in this
interval
way.
notation.
Is this interval notation?
This is interval notation.
Okay.
Range.
Okay.
You just gotta do it.
Keep going, she's gonna write up there. Try to write in a different color other than.
Yeah.
I'll write.
Write it.
Don't write
Write
in red.
Write-
I know.
write it. Use
Right?
every
No,
color.
right?
Yeah,
I used a lot of red.
Double knot. That's the only one. I remember.
Yeah.
Used a lot of red.
Yeah.
Use every color.
That's the only one my
Sorry.
nephew can tie his shoes.
I always forget.
My eyesight
Mr.
is
Ward.
close enough so I can
Right
like
now.
see
Mr. Ward.
not super bad.
What does this make?
This morning.
Oh, Jesus.
I
Sorry,
have
hey,
some
it's
old
cold.
Cheerios.
Sorry, I unplugged it.
Mr. Ward, check this
Did
out.
you just write range?
All right.
Mr. Ward,
Yeah.
you can tie your shoes like this.
I don't need to see it.
Oh!
Is that what your cousin does that you did?
My nephew, yeah.
That's what I mean.
That was
Wait,
cool.
what's your
We'll
nephew?
see that again later.
Wait, what's your nephew's name again?
Okay,
Keaton.
all right, hey,
Keaton.
okay, let's talk about range. Any questions, concerns about the range she has written?
Well, let me see.
Watch your mark.
Wait, she has one scrimmage. We're good. Snacky time.
Okay, hey,
Where are my snacks?
Wait, where's
Well,
the?
my-
agree or disagree?
Here, where's your little?
Agree.
Okay.
Agree.
So, I agree, this is the shortcut for writing range. Because range is an intersection in this case, because there's no breaks. Everything overlapped, and it went up. So she can write it one direction. She can write it from -4 and up. She didn't have to have multiple breaks with intersections, because we're not looking where they overlap, we're looking at just the whole thing. The only way that this would be different on range, because let me explain. Range could have a union. What if it was something like this? Now, the range
Would be a.
would actually have a union because there's an actual gap between this.
Oh my
And
There's
goodness.
a gap.
then the domain would go to negative infinity too.
Oh.
Yeah. Now-
You really just changed everything, what
Now,
is it?
hey, when we're writing
You
this,
should just quit.
the range is a little bit different. So we'll
Why?
start this green part. The only difference would be we would have the negative infinity up to whatever this number is. What is that?
-11.
-6.
Okay, now that makes sense
Negative
now.
11.
-6, and then you'd have a union from -4 and up.
Negative.
But
Remember,
you gotta fix the
small-
domain too, or else it's gonna confuse me.
Oh my gosh.
It's negative infinity, -11 union,
Negative
bracket,
11? What are you talking
not
about?
bracket,
Talking about?
parentheses.
What are you talking about negative 11?
Domain.
Oh, alright. I see what's
Mr. Ward, fix the domain.
Oh, no, not black, in red, in red, in red.
She wants you to use green.
I can't read black.
Oh my gosh.
I can't read red
Is
either.
that
I can't read.
I'm just illiterate.
Mr. Ward, do you have any illiterate students in this classroom?
Illiterate.
Me.
Okay.
I'm not sure about you yet, but
Me.
I almost learned how to read when I was in
Almost.
9th grade.
that's for sure. Alright,
But then I
Okay.
took a 2-year
do we
break.
feel a little more comfortable with the whole domain range?
Yeah.
Okay. You guys seem like you got a great handle on it. That's
I
the
agree.
part that I felt a lot of people struggled with the most last year. I mean, we covered a lot of tough topics. But that one is just a subtle thing that people can get wrong. It's easy to flip a number or two around, easy to forget a bracket. So I just want to make sure. Okay, increasing versus decreasing. This graph has moments of increasing and decreasing. Now it's not flowing continuous. So you would not say that this function is always increasing. It's not always decreasing because there's modes where it's switching. So we don't label it as one. If it was just doing one item at a time, let's say that maybe this graph was gone. Let's say we just had a graph that looked like this,
One corner to the corner.
where it was just doing this. That graph is just decreasing as you go from left to right.
What if it's
It's
y
going
equals
down.
4?
What?
What if it's like y equals 4?
Then it's just
then, okay, if it's
Straight
this, it's no
Two.
longer increasing or decreasing. It's not. It's a constant function.
So, is it discrete?
How long did it take you to figure that out?
No, because it would have too many, it would be continuous. Because discrete was when you have breaks in graphs
Wait,
and
what
you
if
have,
it's x equals 2?
that'd be discrete.
Yes.
Oh wait, x equals, no, because that'd be going up and down. That's still
But
includes
what if it
all.
only has one range?
Hey, for it to be a function,
A is for
hey,
horses.
for it to be a function, for every x, there's only one y number coming out of that thing.
That's the horse.
Well, your x equals 4 is going up and down, it's not a function in the first place.
Oh, that's
Holy
not
cow.
fun.
You guys
All right.
are
Now,
So,
hey, if your graph is doing one thing the whole time, like it's going down the whole time, or it's going up, that's also called monotonic. Monotonic is when a graph's doing
That's when
one
you- isn't that
same
when you
thing the
talk in the
whole
same
time.
wait, I thought monatomic was a type
Isn't
of
that
wood.
when you talk in the same voice for a long time?
No.
Oh, that's mahogany.
Oh my goodness. I can't handle it. Alright. Now, okay. So
my
increase,
goodness.
decrease, it's constant if it's flat. It's not a function, it's up and down kind of thing. Monotonic is when it's doing one item the whole time. It's actually
I
continuous.
just have to go like this.
Okay, let's talk about the last couple things here. Tomorrow, we're going to be going into if we have proportional functions, if we have linear functions. Okay, here's the big thing about linear. Tomorrow, I want to get very good at the different types of linear functions. Slope-intercept, standard, general. What's the other one that I didn't list off?
Characteristics.
Standard.
Standard, linear,
General.
general.
Slope-intercept.
Slope it. Oh, I was gonna say that.
Point slope.
Point slope, that's it.
Standard
All right. So, tomorrow we're going to practice on graphing, looking at the parts, labeling domain and range form, that type of thing.
A plus B equals C.
Squared. A
No.
plus
Okay.
AB equals
We're done,
BC
done
plus
for the day. Make sure you're ready to go for tomorrow.
L.
TUV.
No.
Yeah.
Mr. Ward, check this out. I bet you can't do it.